analytical appliance. Now, analytical solution is a tool that lets you analyze your data or your information. But let's look at each of these terms. We'll get to that, but let's examine what is the need of a high-performance analytical appliance. Let's examine the drawbacks of the existing systems or analytical solutions. Now, the basic type of system that we have available today is the OLTP system, which is a transactional system. It's built to be able to handle transactions, such as sales, recording sales, etc., easily, and that's what it does. It has some basic reporting functions, but it doesn't support any detailed analyses. Examples of such systems include SAP ERP or Oracle ERP. On the other hand, we have OLAP systems, the analytical processing systems, which are purpose-built for analytics to overcome the shortcomings of an OLTP system. They support a variety of analysis and data warehousing. Examples of these systems include SAP BW or Oracle BI. But when you look at the OLAP systems, as the data of the corporation grows in size every day, as it keeps increasing, these OLAP solutions are unable to perform properly. A simple query execution might take 30 minutes or so, and as a result, customers need a analytical tool that has a much more drastic improvement that can offer a lot of improvement in terms of performance. Some attempts were made to improve the performance of these OLAP systems, such as indexing or buffering, but at best they presented a improvement of maybe a factor of 10, but that's it. But when you're talking about billions of records for these huge companies like PepsiCo or Coke, who process millions of sales transactions every day, the performance improvement present is just marginal at best. So if you want to improve the performance of any tool drastically, I think we should start by looking at what is the underlying cause of the slow performance. If you think about it, most of all of the data warehouses or the reporting solutions store data in tables, which are just logical representations of data, but the actual storage is in hard drives or some other physical location. So if a user has a query, or some informational query, the data has to be retrieved from the hard drive or from the physical storage to a RAM or a memory, and loaded into processor cache, and then be presented in the form of a formatted report. So if you look at this whole process, most of the delay is because of the data retrieval. In fact, about 90% of the time is taken per retrieval, and only less than 10% is taken to present in the form of a report. So why don't we start thinking about storing the data in the RAM itself or in the memory itself, which means you basically put the snail on a rocket. You have basically eliminated the cause of the delay. Now this type of storing data in the main in memory is called IMDb, which is not really Internet Movie Database. It stands for in-memory database. So for example, let's look at an analogy. Let's say if a manager has a query the manager wants to know how many sales a store has made in the last 24 hours or so. So he consults the sales clerk, who really needs time to go back to a system and check how many sales there were. But on the other hand, there's a nerd in the same store who can tell what the sales are right away because he has it in memory. You see, the key word is in memory. HANA is a in-memory database, which means the main storage is not a hard drive, it's memory or RAM. so if you'd like to call it that. So it's obvious that if you want to store millions or billions of data in memory, that memory needs to be huge, and that's why SAP is not only providing the software but also the appropriate hardware in alliance with their partners, and that's why the word appliance is used. So they provide the hardware and they provide the software, and that's why the word appliance is used. So some of the hardware partners are IBM, Fujitsu, Dell, HP, and some others, and they provide very high configuration machines which have up to 128 core processors and 4 TB. And actually recently I have been reported of RAM of up to memory of up to 10 terabytes, and I think in the near future we can expect to see 50 to 100 terabytes of memory. So the big question now is HANA an end-to-end solution? Does it support the end-to-end analytical needs of a customer? So what does an end-to-end solution do in the first place? It needs to have a data warehouse, obviously, to be a repository of all the data. It needs to have some way to extract data from the source systems and put it in the warehouse, which is done by the use of an ETL tool, which stands for extract, transform, and load. And finally, to present the data in the warehouse to the user, we need some reporting tools. So what HANA solution offers is the HANA database, obviously, which is the memory database, and ETL tools such as business objects data services, and LT replication server, landscape transformation replication server, and the Sybase replication server, which help load or replicate the data from source systems into the data warehouse. And when it comes to reporting, surprisingly, SAP doesn't provide any reporting tool, and that is because SAP HANA will work with any reporting tool, such as business objects or even Excel. So it's up to the client or the customer to decide which reporting tool they want to use. So what you get in the box is the hardware, which is the main memory and HANA database pre-installed on it, and the ETL tools, and the customer has to choose his own reporting tool. So that's pretty much the introduction to HANA. Thank